Hi guys, we are starting chapter 1, lesson 5 here. So get those notes out in front of you and here we go. So the last few classes, it seems like what we've done maybe hasn't connected with each other. And so today is kind of the accumulation of everything coming together that we've looked at so far. So if we kind of review a little bit, we have looked at variables, right? Like working a problem out if we were given what the variable represents. So if we had x equals 2, we could plug that in and that would be 2 plus 5 and we get the answer, right? We've also worked on simplifying expressions with variables. So if we have a plus 5 plus 6, we could combine our numbers and make this a plus 11, right? And so, and then we've also been graphing. So here's the cool thing. If I had an equation that was like x plus 2 equals y, I could actually turn this into a graph. And so if I plugged in a made up a value for x, like maybe my x value would be 2, and I plugged it into the equation. So my equation is x plus 2 equals y. I make a chart here, and this y is like my answer. So I plug x, the number I come up with x, into where x is, and I solve it. Then I have 2 plus 2, right? So 2 plus 2 would be 4. So that means my y would be 4. If I come up with a number for x that's 1, and I plug that into where x is, I do 1 plus 2, that equals 3. So the only thing that's changing is this x value, right? And then my y would be 3. That's my answer. Let's try 4. So 4 plus 2 would be 6. My answer would be 6. So here's the cool thing. What you basically did is you made ordered pairs that were values in your equation. So what we put into our equation is what we call the input. And what comes out of our equation, the answer, is called our output. So for this, an ordered pair for an input of 2 would get us an output of 4. For this equation, if we put an input of 1, the output would be 3. For this one, the input would be 4, and the output would be 6. So here's another thing. Inputs and outputs, we can give them synonyms. So remember how we called x, the x value, a domain? Well, the input a lot of times is our x value, and it's our domain. Our output a lot of times is y, and that is our range. So now when we think of when I say what's the input for this equation, you might also think of it as the domain or the x value for that equation. When I say what's the output of this equation, you might also say what's the y or the range for this equation. So this is kind of just an overview of what we're looking at today. Let's go back, let's backtrack a little bit and look at our notes. So what we call the equations where we have an input and an output is what we call a function. So this is kind of a big fancy word for describing what we just did. Now, a function though, the domain, so what's another name for domain, right? That's like our x, right? Is paired with exactly one member in the range. So remember, range means y, okay? So I cannot have a y value that has more than one domain or more than one x value. So we'll kind of talk about that in a second. But a function rule is basically is the operation performed on the domain value to get the range value. So the function rule is basically kind of what we call like working out an equation. So for this purpose here, we could say that's kind of like our equation. Hard to read that equation, okay? So we can use a function table to organize and display the input and output. And so that's kind of like what I just did down here, right? We've got a table, so we've got a function table that describes what goes in and what comes out with our equation. So basically what you're subbing into your equation to get the answer. So let's take a look at a real life problem, okay? June is ordering tickets for a show. Tickets cost $12 each, and there is a $3 surcharge per order. Make a function table for 4 different input values and write an algebraic expression for the rule. Then state the domain and range for the function. Okay, this sounds so complicated because there's so many fancy words, but let's break it down a little bit, okay? So we need to make sense of what this is saying. Tickets cost $12 each, and there's a $3 surcharge. So if we were to buy, if we were to buy 5 tickets, our equation would look different as if we bought 10 tickets, right? So the amount of tickets we're actually buying matters. And do we know how many tickets we're buying? I don't think so. So we actually don't know how much we're buying. $12 each, but I don't know how many we're buying. But I do know that every order I put in, like if I put in an order of 10 tickets, or if I put in an order of 5 tickets, or if I put in an order of 100 tickets, it doesn't matter what my order is and how many tickets I'm buying in one order, there's a $3 surcharge. So that means I have to pay $3. Maybe it's a transaction fee or some type of fee that I have to pay for any order that I place. So I could write this equation out as, well, I don't know how many tickets I'm buying, but I know each ticket's $12. So I could write this as 12 times X. And then I have to add my $3 surcharge. Plus 3 equals, well, the amount that I have to pay, right? So we could say Y. And we're going to start to use X as our unknown or amount that goes into the equation, and Y is going to represent our answer now. So we're going to start to be consistent with how we see our variables. We're not going to use A or Z or W or B or whatever as much as these 2 letters. So here is a setup of a function table. So the instructions say make a function table for 4 different input values and write an algebraic expression for the rule. So this is our rule here. This is our rule that we have to follow, okay? And so the table's been made for you. And so our rule will be in this spot, 12. Actually, I'm going to put it in the very top. I'm going to put it right here, 12. X plus 3 equals Y. That's the rule. So now you have the freedom to put in whatever value you would like into the X position, okay? So I would just keep it simple and do easy numbers. 1, 2, 3, 4. Okay, so now I'm going to sub in whatever I put in for X into my equation, into my rule. So I have 12 times 1 plus 3. That equals whatever is my output. So I'm going to just write down all my equations. 12 times 2 plus 3. 12 times 3 plus 3. And 12 times 4 plus 3. So those were all my X values that I put in here. Now I can solve it and write the answer to my problem on the right. So 12 times 1 plus 3 is 15. 12 times 2 is 24. 24 plus 3 is 27. 12 times 3 is 36. 36 plus 3 is 39. 12 times 4 is 48. 48 plus 3 is 51. So basically here what I have are all the prices I have to pay depending on how many tickets I buy. If I buy 1 ticket, I have to pay $15. If I buy 4 tickets, I have to pay $51. So step 2 actually gave us what the equation would be. So it says the phrase tickets cost, this should be $12 each, and a $3 surcharge per order translates to 12x plus 3. Use the rule to complete the table. So we completed the table. Step 3 says state the domain and range. So you did this in your homework or in your lesson the last class, but it's basically listing out what are my x values. Well, domain would be 1, 2, 3, and 4. My range are all my y values, and that would be 15, 27, 39, and 51. Those are my y values. And that's all you have to do. Okay, next step. Graph this function on graph paper, which means now you have these ordered pairs, 1 and 15, 2 and 27, 3 and 39, and 4 and 51. So you basically can plot these points on graph paper and see, actually what you'll see is you'll see a pattern of how the prices change and go up. So I won't graph this one because these are pretty big numbers, but let's do another one together. So I would say the big things we really need to be careful with is coming up with the right equation for the phrase we're looking at, the word problem we're looking at, and then putting in just a few numbers for input and output, or input to get the right output. So, so let's do number 1 together. Each copy of a book costs $18 and shipping is $9 per order. So it's kind of like the last one. Well, it depends on how many books we buy, right? But if I buy 2 books, it's gonna be different price as to 3 books, 4 books, 5 books. So we don't know how many books we're buying. So we're gonna use the letter X to represent the amount of books that I don't know how many I'm buying. And shipping is $9 per order. So that means we have to add $9 to whatever order we are putting in. And so that's my rule, that's my equation. Now I can come up with a few values for the amount of books I buy. So I'm going to keep it simple and do 1, 2, 3, 4. And you can use your calculator for this. I'll let you on your homework and stuff. On your test, you won't need a calculator because I probably won't pick numbers that are quite as complicated. So we can work this out and plug in each value. So 18 times 1 plus 9, 18 times 2 plus 9, 18 times 3 plus 9, 18 times 4 plus 9. Okay, so we can work all of these out. So you can pause the video and work these out if you'd like to. 18 plus 1, 18 times 1 plus 9 is 27. 18 times 2 plus 9 is 45. 18 times 3 plus 9 is 63. And then 18 times 4 plus 9 is 81. So those are your answers. And I'm just going to have you guys do 4 spots, 4 inputs and outputs, so you don't have to do the last little box there. Okay, so the final thing is we have to list the domain and range. So we're getting to the habit of recognizing what is our domain, what's our range. Well, domain is basically anything that's our x value, and range is our y value. So we have 27, 45, 63, and 81. Okay. All right, let's do number 2. The number of girls at camp is 17 less than twice the number of boys. Oh dear, so we've got a lot going on. So we don't know how many girls are at camp. And I think I could say that this would be the amount of girls, right? I'd have to know the amount of boys to know the amount of girls that there are. So is 17 less than, remember less than is a turnaround word, so it's whatever minus 17, right? Twice the number of boys. So whatever boys are, however many boys I have, is twice the amount of boys, and then subtract 17. So twice means 2 times, so 2 times x minus 17 looks like our little equation there. Now, here's the problem though. If I only put 1, 2, 3, 4 down here, like 1 boy or 2 boys, then when I subtract 17, I think I'm going to get negative people. And I don't know if that's possible. So think through what this represents here. And we don't want to have negative people. So I think I would have to have at least, I don't know, we could start with 10 boys. So we could say 2 times 10, and that would be 20 boys, right? 20 boys minus 17, that would be 3 girls left. Okay, so maybe I'll go up from there, 11, 12, and 13. So 2 times 11 minus 17, I would be left with 5 girls, and let me plug that back into the equation. So 2 times 11 minus 17, 2 times 12 minus 17, 2 times 13 minus 17. So 2 times 12 is 24. 24 minus 11 is 7. And then 13 times 2 is 26. 26 minus 17 is 9. So your domain would be 10, 11, 12, 13. And then your range would be 3, 5, 7, and 9. Okay, I'm going to give you guys some time to do 3 and 4. Once you finish it, check back in here and see what you get. I'm going to pause the video on my side, and I'm going to work the problem out and then press play again. And so it should skip straight to what the answer would be. So pause the video, work it out, and I will see you in a bit. Okay, let's take a look at what you guys got. Now, these were harder equations to write out, at least number 3 was. So let's take a look. Tom's height is 10 inches more than a third of his older sister's height. So think of a third of his older sister's height. You could write it as 1/3 times his sister, or you could write it as his sister divided by 3, his sister's height divided by 3. So, so when we're translating this back into our rule, we've got to use x for our unknown, and so I used s here as our sister's height. But when I bring this back down to our rule with our inputs and outputs, we're going to keep it consistent and use x and y. So since it's 10 inches more, it means 10 plus, and then a third of his sister's height, meaning whatever his sister is has to be divided by 3, or finding 1/3 of what his sister is. So 1/3 times x would work too. So you could write this as 10 plus 1/3 x. Now that would work, or x over 3. Okay, so this one was tricky because you kind of had to strategically pick your input values. And if you chose like 1, 2, 3, 4 to put in, then you would have some really ugly fractions to work with. So if you used a multiple of 3 and put it into the fraction and did that, then whenever you do a multiple of 3 divided by 3, you'll get an even whole number, or a whole number, not even, could be odd, right? So it's just a whole number. So 3 divided by 3 plus 10 would be basically 10 plus 1. 3 divided by 3 is 1 here. So these are my answers that I got when I used multiples of 3 going up to 12. And then on number 4, hopefully you put $75 times x plus 15 as the rule or as the equation, and then you could just plug in whatever values. I mean, if you wanted to put 10 nights in, 11 nights, whatever. But I put 1, 2, 3, and 4 because those were just small numbers to work with, and my answers are 90, 165, 240, and 315. Now, of course, you've got to put in your domain and range. So my domain is 3, 6, 9, and 12. And then my range is 11, 12, 13, and 14. And I think you guys can figure out what the domain and range would be for number 4. So I won't write them out, but domain would be 1, 2, 3, and 4. And then range would be 90, 165, 240, and 315. Okay, that's all I have for you guys. Today's lesson was definitely probably one of the hardest that we've done all chapter. So if you have any questions, don't hesitate to reach out to me. And I will see you next time.